All right. The next one, the fun part. So remember rationalizing the denominator? Back in your algebra 2 days, if we had like 1 over the square root of 3, and we wanted to get rid of the radical, we say we don't want to divide by the square root of 3. Well, what would we do? We would rationalize the denominator. How did we do that? We'd multiply by the square root of 3 on the top and on the bottom, and therefore we get the square root of 3 divided by 3. No longer do we have a radical in the denominator. And then we also came up with, well, what about if I had 1 plus the square root of 3? What did we do there? In that case, what we needed to do was multiply by the conjugate, 1 minus a square root of 3. The reason why we want to multiply by the conjugate is because that produced a difference of 2 squares. So in these examples, when you have a binomial in this case, that's exactly what we're looking into doing. We're looking to get rid, what we're doing is we're looking to create a perfect square trinomial. Now, why would we want to create a perfect square trinomial with trigonometric functions? The reason why we want to do it with trigonometric functions is because then that's going to create the Pythagorean identities that we can further simplify. So let's go and take a look at the first example. If you know that the conjugate of this would be a 1 minus a cosine of x, and you multiply by a 1 minus cosine of x on the top and the bottom. So the numerator is going to be exactly as it is. So that's going to be a sine of x times 1 minus a cosine, not cosine squared of x, just a cosine of x. And then in my denominator, what we have here is, again, this is a difference of 2 squares. So this is going to be a 1 minus a cosine squared of x, right? So that's going to be a 1 minus cosine squared of x. And again, think about your Pythagorean identity. Sine squared plus cosine squared equals 1. If you subtract a cosine squared on both sides, this is just equal to a sine squared. So I can actually just cancel that out and say that's equal to a sine squared of x using my Pythagorean identities, which now those will divide out. So my final answer is a 1 minus a cosine of x. All right, the next one, same exact thing. Think about multiplying by your reciprocal. What's the reciprocal in this case? Now, it's important in this case that we just think of like, all right, well, the opposite, the conjugate, sorry. Now my brain is starting to go. This would be a long lesson inside the classroom, but you guys are getting the benefit of the full lesson. So I'm going to multiply by secant of x times a secant minus x. So this is going to produce a tangent squared of x times a secant of x minus 1. Denominator, though, now is going to be a secant squared of x minus 1, or minus a 1 squared. So remember, it was tangent squared plus 1 equals a secant squared, right? So again, you can see how this is going to simplify over to a tangent squared of x, which now those will divide out, and we're just left with a secant of x minus 1. All right. Let's go and do it again. So 1 over secant of x minus a tangent of x. So multiply by the conjugate would be simply multiplying by, I want to do, I wonder what I was trying to do with this one. Doing a lot of sines and cosines. Yeah, okay. What's this? So in this one, I have if I multiply by the conjugate, this would be a secant of x plus a tangent of x divided by a secant of x plus a tangent of x. All right, so we have a secant of x plus a tangent of x divided by a secant squared of x minus a tangent squared of x. Okay, so I think the important thing that I always like to do when I'm looking into these, or when you're trying to simplify this, I can't really simplify anything further here if they're not in the same trigonometric terms, right? So what I'm going to want to do in this case is I'm going to want to rewrite secant and tangent in the same term. So I know 1 plus tangent squared is equal to secant squared. So if you subtract the 1, then you'd have a tangent squared is equal to secant squared minus 1. So I can rewrite this as a, let me just cancel it out because I don't want to rewrite all that. I can rewrite that as a tangent squared plus 1, tangent of x plus 1, right? So now if you think about this, tangent squared of x plus 1 minus a tangent squared of x, now we can say that though these are going to divide out, and now I'm just going, or not divide out, they're going to subtract to 0. So now I'm just going to be left with a secant of x plus a tangent of x. But don't forget here, that's -1, so that's going to be divided by 1. So therefore, since it's just divided by 1, you're just left with a secant of x plus a tangent of x. All right, I don't want to do this one. This one looks exactly the same. So I'm going to do, since we're already this far in the video, let's just make up one and see how it works. I don't know if this one's going to be a good problem or not. So I'm just going to make it up and see what happens. So let's see, we have, rather than tangent, let's do a cotangent of x plus a cosecant of x. So if this works out all right, then I will keep this, okay? So I'll probably update it on there, but let's see how this one would be. So if we were going to multiply this, this one out, so we'd multiply by the conjugate, and again, I'm making up this problem, so hopefully it is going to work. Cosecant of x, so I multiply by a cotangent of x minus a cosecant of x. Okay, so in the numerator here, we're just going to leave this -2 times the cotangent of x minus a cosecant of x. You could distribute that through, but I always prefer to like keep things the way they kind of are in that case. I don't like to kind of ruffle the feathers per se. Like leave it there. If we realize we need to divide it out, then we can. All right, so I think 1 plus cotangent squared is equal to cosecant squared. So if I have sine squared plus cosine squared, if I divide by sine, that'd be 1 plus cotangent squared is equal to what, sine over sine divided by sine, cosine over sine, 1 over sine is cosecant. So yeah, so that I just got to remember. So 1 plus a cotangent squared of x is equal to a cosecant squared of x. Okay, so then in this case, I'm going to get a cotangent squared of x minus a cosecant squared of x. And again, kind of like what we were doing over here, ladies and gentlemen, let's rewrite the cosecant in terms of cotangent. So again, to do that, what I simply can do is I can just, I can subtract the 1 on both sides, and that would be, no, I already have this. Why don't we just rewrite this cosecant in terms of cotangent, which is right there. So I can rewrite this as a 1 plus a cotangent squared of x. There you go. Okay, so now I'm going to have now my cotangents are going to subtract out. Right, so let's cancel that one out there. So now my cotangents are going to subtract out, and I'm going to be left with a -1. So my final answer here is I have a -2 times a cotangent of x minus a cosecant of x. But then remember, there's a negative here, right? So that's all divided by -1. So now those are going to turn to a positive, and you can write your final answer as a 2 cotangent of x minus a 2 cosecant of x. So now we can go ahead and distribute that through. So I'll have to double check that. Hopefully I worked that one out.